In this video, we will talk about translations. So oftentimes we can use translations to help us sketch the graph of a function. The idea is to think about how some function we would like to graph is built up on easier functions. So for example, if we want to, for some function f of x that we have, and we'll look at some concrete examples in a moment, sketch f of x minus h plus k. Well, you might say I start off with my original curve f, and then think about what each of these little things, the minus h and the plus k, are going to do. F of x minus h by itself is going to translate or shift the graph h units to the right, assuming h is a positive number. Additionally, if we add k to it, where here the k is a positive number, what it would do is take our original graph and it just lifts everything up k units. And if you combine those together to get the graph of f of x minus h plus k, you take the original graph, you move it over h units to the right, k units upward. And it's certainly worth noting that if you have y equals f of x plus h, this will translate h units to the left. And if you have y equals f of x minus k, this will translate the original graph of f, k units in that downward direction. So let's look at a nice concrete example. Let's sketch the graph of the square root of x and then use a property of these translations to sketch the function g of x, which is the square root of x plus 3. So square root of x is a function that it starts off at the origin. Its domain is all x bigger than or equal to 0. It goes through 4, 2, so roughly it looks something like this. And it's a common curve. That is, it's a function whose graph we should recognize. So in blue is y equals square root x. And when we think about this other function, g of x equals the square root of x plus 3, what we're doing is taking the square root function, and instead of plugging in an x, we're plugging in an x plus 3. So this is equal to f of x plus 3 with f of x being the square root of x. So that plus 3 tells us that we need to shift, as we saw previously here, 3 units to the left. So when we graph the square root of x plus 3, it comes over 3 units to the left. So roughly speaking, it will look something like this. And that's the graph of g of x equals the square root of x plus 3. So let's do something similar here. Let's graph the function f of x equals x squared, and then think about how we can use these translations to get the graph of the given function g of x here. So f of x equals x squared is going to look, roughly speaking, something like this. It's a parabola opening upward, has a vertex at 0, 0, passes through those points 2, 4, and minus 2, 4. And what we would also like to sketch the graph of is g of x equals x minus 1 squared plus 3. So in order to do this, we just focus in on kind of the two things happening here, x minus 1 plus 3. So we need to shift 1 unit right from the x minus 1 and 3 units up coming from that plus 3. So every point on our graph needs to go 1 to the right and 3 units up. So our vertex is going to be at the point 1, 3. The point that was at 2, 4 is going to move 1 over, so 3, then up to 7. The point that was at minus 2, 2 is going to be at minus 1, 7. So roughly speaking, this curve will look something like that. And note those two curves will intersect on the right when you shift over. So in red, we have the function g of x, the shifted function, and in blue we have that original function f of x.